Hello and welcome to this session on Windows 10, VCL, WinRT, and Universal Windows Platform Support. This session will show the new Windows 10 VCL, UWP, WinRT services and components added to the runtime library. We'll show the new Windows 10 Notification Center component and Windows 10 Share Contract component for both Object Pascal and C++. And we'll see that the notifications come through the Windows 10 Standard Action Center. The contracts are very similar to Intents on Android or ShareSheet on iOS. And the contracts allow you to find what types of applications can consume the content of your application. So for example, if you select text content in your app and you click Share, then you can open it up with a mail or a reading list or a notes application. Plus, we'll also see how to use the classes and interfaces from the WinRT framework. So what does the WinRT Universal Windows Platform Integration mean in RAD Studio 10 Seattle? Well, using the WinRT API definitions metadata, we created a new set of units called Win API units. There's about 40 of these units from the metadata. And we created some helper classes to let you easily manage the hard part of creation of the objects. For example, needing to avoid getting the class factories. And we created a new T-Windows string record to manage the H-string type. So this is a record helper to help manage the new H-string type that was introduced by Microsoft. So for example, this one line of code shows how we can get the year from the calendar. So we first get the calendar year as a string using the method year_as_string, and that returns a new type H-string. So we need to convert it to a Delphi string using the new T-Windows string class using its H-string to string method, and then we can display the calendar year as a string. Delphi 10 Seattle includes WinRT support in the System WinRT and the Win API WinRT units, and the source code gets installed here at source RTL WinRT. For C++ Builder 10 Seattle, the WinRT interfaces are a separate download only for the C++ language, and you can use the Get It Package Manager to install the C++ Windows 10 WinRT. For example, for notifications, here we see how to create the T-Toast Notification Manager. These first two lines of code use the new wrapper framework created in RAD Studio 10 Seattle, compared to these other 7 lines of code used in the older model with build code. So you can see it's much easier to use the new framework in RAD 10 Seattle. Let's now look at the sample app that shows how to use the WinRT support for Windows 10 notifications. This is the notifications project that ships with RAD Studio 10 Seattle. There are both an Object Pascal and a C++ version, as well as FireMonkey multi-device versions. Here we're using the VCL Object Pascal sample. It uses the same T notification component introduced with Windows 8 that you may have already used in previous RAD Studio versions for iOS and Android for FireMonkey multi-device apps. So this T Notification Center component is now also supported on Windows 10. And in Windows 10, the Notification Center has some new features like actionable notifications, also known as interactive notifications. And the actionable notifications allow users to interact with a notification. The Notification Center component has an event called onReceiveLocalNotification. Now the event handler allows you to write a response when the user clicks the notification message in the Notification Center. And in this app, we use this event to log that we have received the notification when we click on the notification. With this app, we can show and cancel notifications. Clicking on the Show button, we see it's the same code that we've used on other platforms like iOS and Android. So first, we create a new instance of notification, and then you fill in the values for name, title, and alert body of your notification. The name specifies the notification name or identifier, and this name needs to be unique for your application. The title is the title of the notification, and the alert body provides the message text for the notification. Then, calling the notification center's present notification method and passing in your notification, this sends the notification through the Windows 10 Standard Action Center. So that's all very cool. I mentioned you need to use a different name for a different notification, and that's because if you send another notification with the same name, you'll only get the one notification with that same name. With this app, I can also cancel notifications. So if I want to cancel a specific notification, I use Notification Center and I call its cancel notification method, and I pass it in the specific notification name. If I want to cancel all notifications, I call the cancel all method of the Notification Center. Let's run this app and see what it does. But before I run it, I want to attach a new Windows 10 style to it. So I do that from Project Options, Application Appearance, and I'm going to add the new Windows 10 blue style to this application, and that will be my default style. So now I can go ahead and run the app. I'm going to run this as a Windows 10 Windows 32-bit application. So there it is with the nice new Windows 10 blue style applied to the application. When I click on Show Notification Number 1 button, we see that our Windows 10 notification appears in the bottom right of our Windows 10 machine. And then when I click on the notification, we see that we get notification received on our app's notification log. So that all works great. And I can do the same with Show Notification Number 2. We get the notification. I can cancel Notification Number 2. I can once again do Show Notification Number 1, cancel Notification Number 1. I can click Show Notification Number 1, and I can also say Show Notification Number 2, so they both get displayed. And now I can say cancel all notifications, both canceling Notification 1 and canceling Notification Number 2. I mentioned earlier that Windows 10 notifications is supported on both a VCL and FireMonkey in both Object Pascal and C++. So here's the C++ FireMonkey version. It's coded exactly the same way as the Object Pascal version we just saw running. Let me run the C++ FireMonkey version and we'll see what it does. This time I'm going to open up the Windows 10 Action Center Notifications panel. So when we click on Show Notification 1, it shows up in our Action Center. If I click on Show Notification Number 2, we also see the notification in our Action Center. If I say Cancel Notification 1, it goes away. Cancel Notification 2, it goes away. If I show them again, and I say Cancel All, they all go away. Click Show Notification Number 2, select it. It shows up in our notification received inside of the notifications log. So that also all works great. I mentioned in the beginning that Delphi 10 Seattle includes the WinRT support. But for C++ Builder 10 Seattle, you need to go to Tools, Get It Package Manager, and from here is where you can install the C++ interfaces for Windows 10 WinRT Access. So that's how you do it. Let's take a quick look at the implementation of the WinRT Notification Center. So we're going to look at the runtime library source code. We're going to look at system win notification. So I'm going to drag and drop it into the IDE. Looking at the method create shortcut, we created a shortcut on the desktop or the main menu for the notification to work. And using the app ID, we can add it to the shortcut, as we do here. So here's where we can use the app ID and add it to the shortcut. And the app ID gets linked to on Windows 10. If you look at the notification and action settings, here's where you can define your notifications, and it lists all the applications that can use your notification. So here's where you can enable or disable the notification feature. And the shortcut is created automatically for you by the Runtime Library Framework. So that's very cool. Next, let's look at the Windows 10 WinRT Share Contract feature. So this is the Share Contract Component app that ships with RAD Studio 10 Seattle with both an Object Pascal and C++ examples. There's also a sample Share Contract Framework app that uses the framework instead of using the Share Contract Component. Looking at the Share Contract Component app and looking at the Object Inspector, we see that we're sharing text and we're sharing images. So this new Share Contract Component, it has many properties that you can share, like data text, data title, description, web address, etc. So for example, the data title and description, these specify the title and the description for the title that appears in the sidebar. The image file property, this allows you to specify an image to share. And all the other properties allow you to share many more information with the target application. So in RAD Studio 10 Seattle, we implemented the Share Contract API that allows you to set your application as a share source. The share target has to be a native Windows application. The Share Contract Component, it has two events, on app chosen and on transfer image. Using the on app chosen event, you can detect what application the user selects to use, and using the on transfer image event, you may provide a custom event handler which lets you pass any stream to the target application. So what is this Share Contract feature? Well, on your Windows 10 machine, Share Contract is the ability for one application to share information with other applications. Now this feature is heavily used on Windows 8 and the Windows 10 platform, but on Windows 8 it was only available for Metro applications. But now in Windows 10, Microsoft allows you to use this on Windows desktop applications. If you look at your Windows 10 Windows Explorer and you select the file, you'll see a Share tab and a Share button. So for the item you select to share, the type of data, such as sharing this image, the Share button lists the apps that the item can be shared with, like we see here. So this item can be shared with my mail application, or if I want a screenshot, I can share a screenshot of File Explorer using OneNote or my mail application. So that's what the Share Contract feature is all about. So these sharing contract apps using the new RAD Studio 10 Seattle Share Contract component, they do the same as the Share button on Windows Explorer. So for example, if you're sharing text, then when we click the share button, it's going to bring up the options that you can share that type of content with. So for example, for different applications that are installed on your Windows 10 machine, such as your mail application, reading list, OneNote, etc. So when we click on the shared button, it's going to set the many shared properties of the shared contract component, and then it's going to call the share contract components init sharing method, and that's going to open up the share panel that lists the applications that can receive our shared data that we are sharing from this app. Let's run this share contract component app and see what it does. But before I run it, I am going to add the new VCL Onyx Blue style that's included in RAD Studio 10 Seattle. So I select it, and I'm going to make it my default style and say OK. So now I'm going to run the app, and we see it comes up with this nice new Onyx Blue VCL style. I'm going to click on the share button. I can now share this data with either my mail app, OneNote, or my reading list app. I'm going to select mail, and I'm going to select my Hotmail account, and we see it creates an instance of the mail app with our data title in the subject, and we have the images of the penguins as an attachment that we are sharing from the app. Now the app also has data like a web address link. In this case, I'm using Embarcadero.com, that we can use in the body of the mail message. So it depends on the intelligence of the application to use the data that we are sharing. If I was to select reading list app as the app, then we see it gets the data title, it gets the description, it gets images, both large and small, and it gets the application name from our app. So on this reading list app, under category, I can select the news, and then I can click the add button to save the reading list. We could then run our reading list app on Windows 10, and we get to see our post. So that works great. Let's now look at the C++ version of the same application. But for this example, I'm going to use the Sharing Contract Framework version of the application, which uses the RTL framework instead of using the Sharing Contract component. So the first thing we do on our form create, here we are going to initialize to create the wrapper using the fshare wrapper. And then, just like we did with the Sharing Contract Component app, when we click on our Share button, we are going to set the shared properties. So here we get to fill in all the information that we want to share, like application name and description, and all the other values are just to assign properties to the framework or the component. So that's all we really need to do. And lastly, we call init sharing from the wrapper, and that's going to launch the sharing process, and it's going to show and list the applications that can receive our shared information. So let's run this C++ version of this Sharing Contract Framework app just to see if we get the same results. But before I do, I want to change its VCL style. So under Project Options, Appearance, I'm going to pick a different new Windows 10 style. So in this case, I'm going to use the new Windows 10 Dark style, set it as my default, and now I'm going to run the app. And now we see the app comes up with our nice new Windows 10 Dark style. So that's really cool. Clicking on the Share button opens up the Share panel that lists the applications that can receive our shared data that we are sharing from the app. I'm going to select the Mail app, and I'm going to pick my Hotmail account. And just like we saw before with the Object Pascal app using the Share Contract component, This time we're using the framework, and we see it still creates the instance of the mail app, and we see our date title shows up as the subject of the mail. We get our images of the penguins as the attachments that we're sharing from the app, and we also get our web address link data that we're using in the body of the mail message. So all of that works great, either using the share contract component or using it through the RTL framework. The last item we'll look at is how to use the new WinRT classes. So from Windows Explorer, you can see all the Win API units that Embarcadero has translated using the API's metadata, and those got installed at source RTL WinRT. So we see units like UI notifications, globalization, and some interesting ones like devices Bluetooth. So this devices Bluetooth, this contains the new Bluetooth and Bluetooth LE classes. So let's take a closer look at devices Bluetooth. So I'll drag and drop it from Explorer into the IDE. Looking into the code, I see I have my constants, I have my types, and I have lots of classes for Bluetooth and Bluetooth LE. Let's say I'm interested in working with Bluetooth LE advertisement manufacturer data. So let me find some classes for advertisement. So here I have all of the values, functions, procedures, and properties that I need to properly manage the Bluetooth data. So that's great. Let's look at another WinRT unit that has the calendar class. So the calendar class is in Win API globalization. Drop it into the IDE. We'll search for the tCalendar class. There it is. tCalendar has a calendar factory, and the calendar factory interface, it has a function to create the calendar. So let's see how we can use the calendar class and create a Windows 10 VCL Universal Windows Platform application. So let's create a new Delphi project VCL Forms application. On the form, let me drop a button. For our tCalendar class, we are going to use our Win API globalization. And I'm also going to add system WinRT for the helper classes. So now in our button click event, we can create our calendar. So create a variable, call it cal. It'll be of type iCalendar. So now we can create the calendar. So cal will be equal to our tCalendar. And now we can call it create. And we see we're using our Win API globalization iCalendar factory. So that's great. Next, we can get the calendar year as a string using its year as string function. And as we see here, it's going to return the new type H string that was introduced by Microsoft. So we need to convert it to a Delphi string using the new Windows string class that we created to manage the H string type. And we can use the Windows string H string to string method to do the conversion. So now we can display the calendar year as a string in a show message box. All right, so let's run this application and see what it does. So I'm going to run the app on my Windows 10 machine as a Windows 32-bit application. Click on the button and we see the show message with the current year 2015, so that works great. This was a quick example on how to use the calendar class and create a Windows 10 VCL Universal Windows Platform application. Another detailed example using the calendar on Windows 10 is this project calendar example that ships with RAD Studio 10 Seattle. So this app will only run on Windows 10. This app also uses the WinRT API globalization and the system WinRT units for the helper classes. In the last app, I used tcalendar create, but this example is using tcalendar factory create calendar. When we run the app and we click on it show data, we see we get all this great calendar information in different languages: Gregorian, Japanese, Hebrew, and Hygeri. So that's great. This ends this session on Windows 10 and the VCL, WinRT, and Universal Windows Platform. For additional resources, look at the examples for Windows 10 notifications and Windows 10 sharing contracts for both Object Pascal and C++. For Delphi 10 Seattle, look at the new Win API units for WinRT. For C++ Builder 10 Seattle, use the Get It Package Manager to install the C++ interfaces for Windows 10 WinRT Access, and look at the doc wiki for the Windows 10 notifications and the new Windows 10 sharing contract components.
Al, there were a few questions that came in, and Jim as well. Jim, there was the question about notifications and how apps work for different users logged in or different machines they're logged in on. Uh-oh. Or Al, either one, Jim or Al.
Yeah, I'm here.
Had mute.
Okay.
The notification is a local notification. It's not a broadcast notification.
That's correct.
Okay. And Al, there's a question about why are we using resources and with WinRT?
That's a great question. So, what we liked about it is, WinRT was native code and it was focused on performance. So for us, RAD Studio, Object Pascal, and C++ folks, it was perfect to integrate it inside of WinRT. And if you don't know, WinRT is not this new technology, it's the old COM stuff we knew about. So it was very easy for us, and we didn't have to spend too much time and resources to happily get it integrated inside of RAD Studio 10 Seattle. And then because of it, we were able to add the cool new Windows 10 features like notifications and share contract.
Yeah, it's important that the Win32 is not going away. The Win32 API is still a part of Windows 10. But a lot of the newer features, like Al mentioned, the notification share contract, are exposed through WinRT. So, for example, Windows 10 added support for beacons through its Bluetooth LE support, but it's only exposed through the WinRT layer. It's not exposed through the Win32 layer. And so our previous Bluetooth implementation used the Win32 implementation API, and so we weren't able to get access to beacons. But now that we have the WinRT support, we're able to do beacons in the future, hopefully. So it's not that we're trying to support the Microsoft tablet, Surface tablet that only ran some applications. It's that we're going to support the new API. So it's WinRT, the API, not WinRT, the tablet that Microsoft abandoned.
Great point, Jim. So you remind me of, so if I recall, I think starting with Windows 8, WinRT became the default application programming interface. And as Jim mentioned, to be clear, WinRT is not going to replace the Win32 API that's been running underneath all Windows applications forever, but it's going to augment it. So Microsoft decided to add these new APIs instead of adding into the Windows 32-bit layer. So they think it's better to use their new WinRT to do that. So Microsoft has had its reasons for doing this, like it's object-oriented and it's at the same level as Win32. And it's important to note that this this WinRT, it's not like the .NET framework that is managed code. So WinRT is native code, and it's focused on performance. So that's why it was great for us with RAD Studio to integrate it with WinRT.
And we've been integrating COM objects and type libraries and all of that going back to what it was, Delphi 3 and beyond.
That's correct. And Microsoft did this right. You said they wanted all of the parts, all of the parts of the WinRT API. They were all designed to be asynchronous, meaning, according to Microsoft, if a function takes less than 50 milliseconds, then this function needs to be asynchronous. So that was nice that they did that.
Yeah, Al, there was a question, sort of two-part maybe. What about being the receiver of a contract?
So let me see this. So
actually, that's the Project Centennial is going to allow for that for a Delphi application in the future. In order to be a receiver of a contract, you have to be I can't remember the term they use, Windows UWP, Universal Windows Platform, and the Project Centennial is going to allow native Delphi applications to run as full UWP applications, so that they will be able to have access to all the cool features of that platform, including the ability to be able to install and update through the Windows App Store. So that's coming in the future.
Yeah, and we're tracking that project with Microsoft internally, as well as, was it Project Astoria? I think someone blogged recently they took an Android APK file and ran it on a beta of Project Astoria on a Windows phone. So
yep,
that's pretty cool.
Not modification at all. Really cool, yeah.
Yeah. So there's always going to be more to come. I think that's the subtle thing about Windows 10 release, is that that's the Windows 10 release or the last major release of the operating system, but now there's all these other projects that will be showing up over time that add functionality to Windows 10. So instead of them being Windows 11, Windows 12, or whatever, they'll just be new subsystem functionalities, and we'll make sure that Delphi and C++ Builder can integrate into all of those things that are added in the future.